Hello everyone, welcome to my channel. Today we'll be looking at pointers, arrays and structures. But today's objective, I'll introduce you to pointers, to arrays, pointer into arrays, references. We also look at structures, union, enumeration. Yes. So when you see pointers are variables that store the address of another variable. Pointers can be used with any data type. That it can take integer, the float, the double, the character. Integer can take any type of data type. Yeah. So how do we create pointers? A pointer can be declared in the same way as any other variable, but with an asterisk symbol. So this is the structure. You have to have a data type and then the name. So you have int ptr. So assigning address to pointers. The address of operator determines the end of any variable in C++. Here's an example. So we are assigning an operator into the address. So differentiating a pointer, the process of accessing the value present at the memory address pointer by the pointer. The process of accessing the value present at the memory address pointed by the pointer. So you want to find out what is in the pointer. So you have to print out, and then you bring the asterisk and then the name to print out what is in the pointer or what you have assigned into the pointer. Yes. Now let's look at modifying the pointer address. A pointer can be modified to point to another address if it's of the same type. So here's an example. So you can see we have two variables, and then one is one, but in one we have two variables, that's a and b. We have a equals b, a equals 5, b equals 2, and then one is being pointed, one of them is being assigned to ptr, the other is also being assigned to ptr. Yes. Now let's look at data size of pointers. Equal data size of all pointers based on the operating system and the CPU architecture. So we can have the 8 bytes for a 64-bit system. We also have 4 bytes for a 32-byte system. So yeah, that's size of data size of pointers. We are going to try them. So So we can see the sizes over there. It have given us the size in which it contains. Let's go back. Yeah. Now we have special types pointers. We have the wild pointer. It contains random memory access. Random memory address that may or may not be valid. That's int, asterisk, and ptr. We have the noun pointer to non-valid memory location by noun. Initialize a pointer that does not need a memory address pointed to. Special type pointer. We have the void pointer. Point to values with no particular type. The dangling pointer. Point to earlier valid address even though reference memory has been erased. Let's look at reference. A reference works as an alias for an existing variable, providing an alternative name for it and allowing you to work with the original data directly. Reference versus pointers. A pointer allows us to pass potentially large amounts of data around a low cost. Instead of copying the data, we simply pass its address as a pointer value. Now, creating reference. We use the ampersand. It's used to create a reference. So here's an example. So we have the variable, and then the reference is, so the ref is an reference to x. Now, application of references. Passing arguments by references. So here's also an example of it. We have the variable, and we also have a variable. We have a value called modified value with x in bracket. Yeah. So now let's see properties of references. References allows you to access. So it allows you to access a reference which is that the name syntax as the name of the object. A reference always refers to the object to which it was initialized. There is no noun reference. So we are done with it. Let's look at arrays. An array contains multiple objects of identificational type stored sequentially in memory. Individual objects in an array are called array elements. Array element can be addressed using index or subscripts. So the syntax, we have the type and the names in bracket the size. So the integer, the data type, we have, for example, we have the float, and then the name, which you can give it, maybe you can name it ALT, anything, and the size, and the size. So we want to call out the size. Let's continue with the index of arrays. So index specifies the position of element in an array. It starts from 0. So when you have an array, when you look at this, for this example, you see we have 10, but it will start from 0 and end at 9, which making 10. So that's what this statement is trying to tell us, that it starts from 0. The subscript operator, so that's it, is used to access individual array elements in arrays. So you can see we have the 0, 1 till 9, until we get to 9, making 10. Now let's see, initializing of arrays. Initializing arrays refers to defining the elements it contains. A list containing the values for the individual array elements is used to initialize the array. So here's an example. as you can see. So accessing array element. Accessing array element refers to reviewing individual array items. So this is the structure. We have the array name and the index. So example is the num3. So we have multi-dimensional arrays. Arrays with columns and rows. We have the two-dimensional arrays. But first you need to have the data type, the array name, and then the size. So you can have size 1, size 2, and then it goes. So declaring two-dimensional arrays. So two-dimensional arrays have row and column. Can be visualized as a table or a matrix. So the first 4 is a row, and then the second 4 is a column. We say this. Now the same for the three-dimensional arrays. Now we are done with arrays. Let's look at trust. Trust is a sequence of elements of arbitrary types used to create user-defined data types. So here's an example. So we have trust address, and it contains all the elements. Or it contains all the elements called members. So all these are called members. So as you can see, so how do we create trust variable? After creating a trust variable must be created. So you need to have trust and name, the name of the variable, and then the name. So you can see, So creating a trust variable with definitions. So we have trust, name, and then the type, and then you have the members. So here's an example. You have trust student, int age, child gender, and then all in the curly brackets with a name. So we can call Julian, and then we will have whatever is in here. So you can see Julian age, and then it prints out whatever is in age. Now we have assigning a trust member. So you first need to have the variable name, and there's a dot. After you're giving the variable name, you have to bring the dot, and then you call out the member, and you put in the value which you want to put in. Now let's look at union. The union is a trust that holds the variable of just one of its elements, and just one of its elements at any one time. So it just only holds one member. So you can only call out one member. You can't call multiple members, not as compared to the trust. Yes. So this is how it looks like. If you want to create, you have to have student in union, student, integer, age, the character, race, gender, and then so you have to have the union name and the variable name. So let's add some examples. If you want to access any member from a union, you have to use the dot operator. So the union variable, and you use the dot the dot operator to call out the member in the union. Yes. So if you want to assign you want to assign a variable, or you want to assign a value to in a union, you use the equal sign operator to assign a value into it, or you need to use the equal to assign a value into it. So here's an example, and then you have Julian.age, and then it's assigning 23 into the union in age, so the member which is in age. Now let's look at trust versus union. So for trust, it allocates memory for each member variable sequentially. The size of a trust is the sum of the size of its elements. Members can be accessed independently at any time. Used to group related data of different types. And for the union, it allocates memory only for the largest member variable. All members share the same memory location, the size of the union, the size of its largest member. Only one member can be active, which is bad, which I won't use, but it's part of the whole C++ system which you need to know. Now let's look at the enumeration. To call out the enumeration, we use the enum, the e and num. It's a type with a set of names, constants called enumerators. It holds a set of integer values specified by the user. The possible values are named and called enumerators. Two types of enumerations. We have the enum classes and the plain enums. So for the enum class, use classes for defining enum, and so we are classifying them. So and let's look at the plain enum. It can be unnamed, and unnamed plain enums are used when a set of integer constants are needed rather than a type to use for variable. So here's an example of it, as you can see. So this is the end of today's session. I will continue in our next session. Thank you. Bye.